Hello all. Today I want to talk to you guys about the multiverse intersection theory of the universe, which is also commonly known as the string landscape theory, which is part of the anthropic principle. In particular, the anthropic principle is supposed to explain one of the basic problems that scientists have discovered with the universe, and that's that the universe appears to be very finely tuned. In other words, there are certain values, certain constants in use. Things like the mass of the proton, the value of the gravitational force, the strong nuclear force. There's other forces. There's the value of pi. There's the equations which physics uses to govern the universe and things like that. These all seem to be very precisely oriented towards a universe that is very finely tuned. It seems to be designed almost to support life, and for some strange reason also to generate black holes. And the anthropic principle is an attempt to explain why these constants are as they are and why the universe is as it appears to be. The explanation that I prefer to look at is, like I said, I call it the multiverse intersection theory, but it's commonly known as the string landscape theory. The explanation goes a little bit like this. We are essentially three-dimensional beings, as we can tell. We have the dimension in the up-down dimension, we have dimension in left-right, and we also have dimension in forward-back. So there's three dimensions here. We also actually are existent in a fourth dimension as well, which most scientists call time. In other words, there is a three-dimensional creature that is me right here, but there was also a three-dimensional creature that was me at the time that this video started and at the time that this video will end. So I'm really taking up an area not only in three-dimensional space, but also an area in time. So I'm really a fourth-dimensional being, and really all of us are, and this is why a lot of physicists call the universe space-time, because space and time are intertwined. Another thing that I'd like to point out is that there's this concept in physics of location of things. For example, I'm currently sitting in front of my desk, but you could say that I'm also at a very specific position in the x, y, and z coordinate plane of the universe, whatever that happens to be. I also am at a specific fourth dimension. I'm at a specific point in time right now. So, in a sense, I'm a fourth dimensional being that occurs within a range, but I also exist at a particular point in that fourth dimensional space at the moment. Now, I also want to talk about the multiverse intersection theory in terms of the fact that what it basically says is, suppose that you look at the universe as more than just four dimensions. Suppose you look at it in terms of extra dimensions. String theory actually has proposed this exact idea, and it becomes a bit of a necessity to have a 10 or 11 dimensional universe with string theory. So let's give these extra dimensions some names. Let's say that one of these dimensions happens to be the value of the mass of a proton, which is one of the basic constants of the universe. Suppose that if you were able to move along this dimension, you could vary the mass of a proton, which is one of the basic properties of the universe. Well, you'd get some pretty interesting effects. What you'd end up with is, you'd end up with a whole variety of different universes, all of which look very, very different. Now, they're not actually different universes. What they are is, because we can only perceive four of those dimensions, that extra fifth dimension that we can't perceive, well, we wouldn't be able to see it. But what would happen is that it would have a number of other effects with other objects in the universe that we could see and we could measure. So it would have all kinds of repercussions, if you will, including all the way back to the very beginnings of the universe, however you believe that happened. So all of these different properties, let's say the mass of a proton, the value of a gravitational field, the laws of physics themselves could all be separate dimensions. You can invent as many dimensions as you like, and in theory, if you could travel along any of them, you would get the appearance of a very, very different universe. Many of these universes, in fact, would have a combination of factors which would cause, if you believe in the Big Bang, would cause the Big Bang to only last a mere number of minutes or hours or not at all. A whole variety of different things. You could have universes that had such an incredible Big Bang, and that gravity, if it was a lot less, you'd end up having virtually no effect, and so matter wouldn't have been able to form, or planets and stars wouldn't have been able to form. Certainly planets, and therefore life, would not have been able to form. Now here's the important point that I want to make. We are all, in this universe, we're observers. We are entities, for lack of a better word, that is capable of looking at the laws of physics and trying to figure them out. And we're capable of asking the question, why is the universe as it is? That simple fact that we are here, that we are able to ask that question, means that this particular universe was capable of producing those effects. In other words, if you were to move to another universe, and when I say move to another universe, I mean alter the other dimensions into a state which the four-dimensional universe that we're able to perceive would be vastly different. If we were able to move to one of those other states, we would see that the vast majority of them, of those other states, are not conducive to producing observers. They're not conducive to producing anything that's capable of asking the question, why am I here? Therefore, you have to understand that the universe is as it is, not because it was guided along by anything, but simply because we're here to observe it. If the universe had been different, in other words, if there was another universe that was conducive also to generating observers, it may be producing observers. There may be observers in it, asking why is the universe so finely tuned in this way, which is very different than why we're asking why our universe is so finely tuned this way. We may both be in the same universe, but there may be enough dimensional separation between us to where we can't recognize each other. What's very interesting about this is that it makes the question of why the universe is so finely tuned largely irrelevant, because the universe is every different way. It isn't just one specific way. So if you want to ask why is it that the mass of a proton is this value, well, the answer really is that the mass of a proton is all values, and the particular value that we happen to be located at in that many-dimensional multiverse, at that particular location, it just happens to be conducive to generating observers, namely us. So that's why it is there. It's not that it's there for a reason, it's that we have managed to find our location in the multidimensional universe, and that location is this value.